10th CBSE. The same lesson, that is the acid, bases and salts. Now today we are going to discuss about the bases. The water bases. As the acid we define, the acid are the substance which dissociate H plus ion when they are mixed with the water. Same here. The bases are the substance which dissociate OH, that is the hydroxy ion. So what are the bases? How we are define it? Bases are the solution. Bases are the substance which dissociate or ionizes or dissociates in water to form OH minus, that is called hydroxy ion. Okay, before move further, I must want to tell you, we are actually talking about the alkali. Okay, alkali are the bases that are generally used in the laboratory. What are alkali? Alkalis are water soluble bases. There are actually two types of the bases. One is called the water soluble bases and one is called the non-aqueous bases. The aqueous bases are called the alkali, and we are talking about the alkali here. So when we dissolve bases in water, what happens? OH negative, that is the hydroxy ion is formed, and when hydroxy ion is formed, we call it the bases. Again, as I said, there are two types of bases. One is called strong bases. Same as the acid. If it dissociate completely, what happened when it dissociate? Dissociate means they release OH minus ion, OH negative, hydroxy ion. If it dissociate completely, it means all the hydroxy ion must release out from it. Then it is called the strong base. Second is the weak base. What is the weak basis? The basis, if it dissociate partially, then it is called the weak basis. There are two types of bases. One is called the strong base and one is called the weak base. Now let's move towards the properties. And first is the physical properties. Are we able to identify the bases with the help of taste? As we are able to identify the acid. Acids are sour in taste. What about the bases? Bases also has a definite taste. Bases are bitter in taste. So all the substances which are bitter in taste, actually they contain bases. So bases are bitter in taste. One more important feature which is present in the base. After that, I want to know an example of base by you. Okay, that is the feel. Okay, the bases are soapy in touch. Feeling. What is the feeling? It is soapy in touch. Now you are able to give the example of bases. All the soaps are basic in nature. All the soap, when you take the soap between the finger, you feel the soapiness of that soap. That is the basic character. All the bases are soapy in taste. Then soap is basic in nature. Maybe it happens with you anytime when you're taking the bath, that some part of the water in which the soap is there must enter in your mouth. And if you remember, the taste of that water is the bitter, with the bitterness. That is the basic nature of the soap. So soaps are basic in nature and the bases are soapy in touch. Okay. Now here also the indicator effect is there. That is the effect of indicator. Actually we have to compare the properties of acid and base with the help of the indicator. You must remember about the three indicators that we are already studied in the acid section. First is the litmus paper. Second is methyl orange. Methyl orange. And third is phenolphthalein. Phenolphthalein. The three indicators, chemical indicators that are generally used in the laboratory are mentioned here. What happened in the acids? In acids, the blue litmus turns red. What happened here? In litmus paper, we have to use the red litmus paper. Bases in the presence of water turn red litmus blue. It converts red litmus to blue litmus. So if the litmus paper converted from blue to red, it means it is acid, and if it converted from red to blue, that it means it is basic in nature. Second is methyl orange. In acid you must remember methyl orange, the color of methyl orange in the presence of acid converted to pink. Here this color converted to yellow. If the methyl orange is converted in some yellowish color, then it means it is basic in nature. And what about the phenolphthalein? In the presence of phenolphthalein, the color of base converted into pink. Okay, if it is the character of base. Now what is the character of acids? You have to compare it. Okay, bases convert red litmus blue. Red litmus blue. What about the acid? Acid convert blue litmus red. Methyl orange, it converted yellow, it converted it into pink. Phenolphthalein, it converted it into pink. Acid is the colorless. So this is the comparison of indicators between the acids as well as the bases. One more property we are discussing with the acid also about the electrical conductivity. Here also electrical conductivity. Electrical conductivity. Bases are also good conductor of electricity. The strong bases are good conductor of electricity. All these are the physical properties of bases. Now let's move towards the chemical properties. Now chemical properties of bases. Okay. Now what is the first chemical property? When base combines with metal, again they form the salt and hydrogen. Reaction of base with metal. Okay, what happened when the base combines with metal? It forms salt. Okay, when metal is there, metal combines with base, and what happened? Salt is formed with releasing the hydrogen gas. Here this equation is very much important. Why this equation is important? Because the salt which is formed is not a normal salt. It is something different as compared to the acid. So you have to must remember two equations in this sequence. First, metal is the zinc. When zinc combines with base sodium hydroxide, the salt which is formed here is called sodium zincate. The salt which is formed is called sodium zincate. That is Na2ZnO2 with releasing H2. This is called sodium zincate. This is not the ordinary salt, so you must have to learn this equation. Now check the balancing here. Sodium Na1, here Na is 2. So we have to put 1, 2 here. What about the zinc? Zinc 1 is here. Here zinc is also 1. What about the O? O2, here O2, H2, here H2. Now this equation is balanced. One more equation you have to learn in this heading, actually with aluminium. Aluminium combines with sodium hydroxide, but this reaction is completed in the presence of water. And what happened in this reaction? The substance which is formed is called sodium meta-aluminate, that is NaAlO2, by releasing of hydrogen. Okay, now check the balancing of the equation. And here, so this is sodium meta-aluminate. Okay, now check the balancing here. Na1, here Na is 1. Here O is 1, but here 1 plus 1, 2. Here O is 2. Aluminium 1, aluminium is also 1. H is 2 here, H is also 2 here. It means this equation is already balanced equation. Now this second chemical property of the base, that is the neutralization reaction. There is no need neutralization reaction. There is no need to repeat this equation again and again. It is the combined acid combines with a base, salt and water is formed. So this is the neutralization reaction. So these are the few chemical properties of the bases. Now let's move towards the uses of the bases. Uses of bases. One more important thing is there. When we talk about the bases, actually we are talking about the alkali. What is alkali? Alkaline is water soluble bases. Water soluble bases. There are two types of the bases now. One is the non-aqueous basis and one is the aqueous basis, that is called the alkaline. And actually alkaline is used in the laboratory for all the reaction purpose. We are talking about alkaline only. Okay, so what are the uses of bases? Sodium hydroxide. Sodium hydroxide. A very much commonly used base, it is NaOH. It is the important thing to making the soap preparation, soap manufacturing. The sodium hydroxide is required. So this is the use of the sodium hydroxide, and sodium hydroxide is in base. Alkaline base, one more is there, that is called potassium hydroxide. Potassium hydroxide. Potassium hydroxide is KOH, and this hydroxide, it is used in the batteries. It is used in the batteries. Okay. One more base is there which is very much important, that is the calcium hydroxide. Calcium hydroxide. It is CaOH2. I'm going to change this, CaOH2. Calcium hydroxide. Calcium hydroxide is used for softening of hard water. Softening of hard water. It's very much important use of the calcium hydroxide. One very much commonly used base is the magnesium hydroxide. Magnesium hydroxide. Magnesium hydroxide, MgOH2. Magnesium hydroxide is used as antacid. Antacid. We have to learn about the antacid in this lesson only. So we must discuss about the antacid in any other class. Okay. So these are the various uses of the bases. One more thing, just like the acid, bases are also classified into two parts. One is called strong base and one is called weak base. How can we identify which is strong and which is weak? It is depend upon the ionization capacity. If it ionized partially, it means it is a weak base. But if it ionized completely, then it means it is a strong base. Ionizing, what is the meaning of ionizing? It means the releasing of H minus ion. If all the H minus ion releases in the presence of water, it means that is a strong base. And if it is half of the ion is released and the process get reversed, then it is called the weak base. So this is about the base. Now salt. The salts. Salts, which very much know, when acid reacts with the base, then salt is formed. So what is salt? Salt is actually ionic compound which contain positive ion and negative ion. Ionic compound, it means the composed of one positive and one negative ion. But condition is there that positive ion is not the H plus ion and negative is not the OH minus ion. Positive means cation, negative means anion. But it does not contain H plus and OH minus ion. But it is an ionic compound. Now how can we define it? Salt is an ionic compound. Ionic compound. What is the meaning of the word ionic compound? It means it is made of the ion only, which contain two ion, which contain positive ion, and we call the positive ion that is cation. Other than H plus ion. If H plus ion is there, it means it is an acid. But H plus ion, other than H plus ion, and negative ion, or we call it the ions. Okay, negative ion is called anion. But again the condition is there, other than OH minus ion. So what is salt? Salt is ionic compound which is made up of two ion, one positive, one negative, one cation, one anion. But that cation and anion is not H plus and OH minus ion. They are other than any. Okay. For example, common salt. Common salt. What is common salt is? NaCl. Na plus and Cl minus. One is cation, one is anion. They form the common salt. So this is the salts are the ionic compound, but ionic compound other than the H plus ion and OH minus ion. There are various families of the salt. Families. Okay. Families. We are able to identify it. If it is chloride salt, we call it the chlorine family. If it is nitrate salt, we call it the nitrate family, sulfate family, sulfide family. So there are various families of the salt is also there. But we have to study about the classification of the salt. Okay, that is the important thing. That is the classification of the salt. Classification. On the basis of this classification, we are able to categorize the salt in three different forms. As we know that salt is formed when acid combines with base. It neutralizes to form the salt. The salt is formed by the combination or neutralization of acid and the base. So on that neutralization process, there are three types of salt. Okay. The first type of salt is called the normal salt. Normal salt. This is normal salt. That is the common salt. How the common salt is formed? It is formed by the combination of a strong. It is formed by the combination of a strong acid and a strong base. When a strong acid combines with a strong base, then the salt is formed is called the normal salt. For example, a strong acid HCl combines with a strong base NaOH, and as a result of that, NaCl is formed by releasing water, and it is called normal salt. The second is called the acidic salt. Acidic salt. If a salt is formed by the combination of a strong acid but weak base. When it is formed with a combination of a strong acid, you make the sentence, it is formed by the combination of strong acid but weak base. Then the salt is called the acidic salt. For example, strong acid is HCl and weak base is NH4OH, ammonium hydroxide. When these two combine together, what happens? The salt which is formed is NH4Cl, ammonium chloride, by releasing water, that is H2O, and this is acidic salt. Okay, because acid is strong here, so nature of this salt is the acidic. One is called the basic salt. Basic salt, it is formed by the combination of a strong base with weak acid. Weak acid. When these two combine together, the salt which is formed is called the basic salt. A strong base, that is NaOH, combines with weak acid, that is acetic acid, CH3COOH. When these two combine together, what happens? The substance which is formed is CH3COO Na plus H2O, sodium acetate. Sodium acetate is formed, and sodium acetate is the basic salt. What are the various uses of salt? That we have to discuss in our next classes, because in our lesson there are example of few salts. We have to learn the preparation method, we have to learn the properties, and we have to learn the uses of that salt also. So we have conclude our topic here only. In next class we must discuss first about the pH and then the various type of salt, their preparation method and uses.